So here, there's a typical SQL injection example. We're in an online shopping site and would like to see a laptop. The URL for the laptop can be seen on the slide. The SQL query to bring the details of the laptop will be something like this. With an unexpected parameter, the SQL query becomes just like this. Now, what if we tamper with the ID parameter and send the ID string like this? Okay, suppose that we have a method to authenticate user login. Now, it looks like Java code, but it's not. It gives errors if you try to compile the method in any language. Please, just for now, focus on the algorithm. The method takes username and password as parameters and decides if the user can log into the application. It returns true if the user is valid, otherwise it returns false. So let's build the SQL query using the parameters which come from the login form. The single quotes are to start and end the string values in a SQL string. Plus signs are for the string concatenation. SQL string is executed, and corresponding records create the result set. The method returns false if no records are found, otherwise returns true and lets the user log in. If we enter user1 as a username and 1234 as a password, the SQL string will be select star from users where username equals user1 and password equals 1234. And the method will return true if there is a record matched, which means if there is a user named user1 and if this user's password is 1234. Now, suppose that we enter 1, single quote, or 1 equals 1, double dash as the password. Now the SQL string will be select star from users where username equals user1 and password equals 1, or 1 equals 1, double dash. In SQL queries, double dash means that the rest of the line is the comment and will not be executed. Here we use the double dash to get rid of the redundant single quote. Since 1 equals 1 is always true and the logical operator is OR, where clause will match for all the records of the users table, which means the size of the result set will be the total number of records in the table, and the method will let us log in even though we don't know the password. So let's make an SQL injection example. So for this demo, we use DAM vulnerable web applications. Go to the OWASP Broken Web Applications homepage. Log into the application using user credential. Go to SQL injection page. Now on this page, when we submit the user ID, that user's name and surname are displayed. If we try to submit a single quote with the ID number, we get a syntax error message. And we see that the database system is MySQL, and there is a redundant single quote in the SQL string, which means our input is not sanitized and the single quote has arrived in the database. Now, if we succeed to create a valid SQL string, we may get the results of that query. So let's submit this. 1 single quote or 1 equals 1 double dash space. The database system of the application, MySQL, requires space characters after the double dash, so don't forget to put a space after the double dash. And what do we have here? Now we have the name and surname information of all records. We found the SQL injection vulnerability and see the entire table's name and surname values in one go. So, if we can do this, what else can we do? SQLMap is a little bit complicated, but a very powerful command line application to exploit SQL injection vulnerabilities. You can download and use this free application in any platform, and it's embedded into Kali Linux. SQLMap has a lot of parameters, so you can use -h parameter to learn more. For now, let's build the SQLMap command. The first parameter is the URL. Since the program analyzes all the parameters, we don't need to give, but we know that the ID parameter is vulnerable. We can give it as the second parameter. Since we need to have a valid credential to reach the page in DAM vulnerable web application, we have to give SQLMap a valid cookie. Not necessarily, but it is better to teach SQLMap when it gets a valid result. In this example, we can give a static part of the valid page, first name, and last, we have to say what we want from SQLMap. It says the banner is 5.1.41.3 Ubuntu 12.6_log. Let's ask for the current database at this time. --current-db. The current database is DVWA. Let's list the tables of the database. So here we go in deep. Let's dump the user's database. It says the database management system is MySQL. We already know it, so we can skip to other database management systems. In questions, the default answer is shown in all caps. If you hit enter, the default answer is selected. It says the ID parameter is vulnerable, so we can skip other parameters at this point. It found hash values inside the table and asks if we want to save it for further use. Moreover, it offers to crack the hash values. So let's use SQLMap's default dictionary in this example. And finally, we have the dump of the user's table, and hash values are cracked. Good job. Blind SQL injection is used when a web application is vulnerable to an SQL injection, but the results of the injection are not visible to the attacker. The page with the vulnerability may not be one that displays data, but will display differently, depending on the results of a logical statement injected into the legitimate SQL statement called for that page. This type of attack has traditionally been considered time-intensive because a new statement is needed to be crafted for each bit recovered. And depending on its structure, the attack may consist of many unsuccessful requests. Now, thankfully, there are several tools that can automate these attacks once the location of the vulnerability and the target information has been established. Now, we already know one of them. It's SQLMap. An SQL injection is a well-known attack and easily prevented by simple measures. With most development platforms, parameterized queries, also known as prepared statements, that work with parameters can be used instead of embedding user input in the statement. A placeholder can only store a value of the given type and not an arbitrary SQL fragment. Hence, the SQL injection would simply be treated as a strange and probably invalid parameter value. If the application is developed with an object-oriented programming language, using object relational mapping libraries avoids the need to write SQL code. The ORM library, in effect, will generate parameterized SQL statements from object-oriented code. A straightforward, though error-prone way to prevent injections is to escape characters that have a special meaning in SQL.